Okay, this video goes with the exercises practice that come from the Jurgensen text. So let's look at these. If OE is equal to 4 and WE is equal to 8, name two segments congruent to WE. And they're telling us that this is a parallelogram, CREW. So if EW is 8, CR must be 8. So CR is going to be congruent to WE. And okay, so we have a 4 and an 8. That gives us like a 3, 4, 5. Well, this gives us a 10 using the Pythagorean theorem. This is a 4, that's a midpoint, that's a 4. So it turns out that all these sides are congruent, so we could say that also CW is a congruent side. And going up here, if this is 8, W is equal to 8. No, this is bisected, this is bisected, this is going to be an 8, it's going to be a 4. Yeah, that lets all of these basically be 10s. Because with the 4, maybe I'm doing that wrong. Let's look here. Let's back up here a second. Might have to blow up this a little bit. And we'll look at just one triangle. Zoom in a little bit more. Okay, so they're telling us that WE is 8. And they're telling us that OE is 4. So if we do 4 squared plus, call this x squared equals 8 squared, we got 16 plus x squared equals 64. Take 64 away from both sides, we got x squared is equal to 48. And x is going to be the square root of 48. 16 times 3 makes 48. Square root of 16 is 4, so we have 4 root 3 for x. So this is 4 root 3. And since these bisect, this is also going to be 4 root 3. Since this is a parallelogram, these bisect each other. This is also going to be 4. And using the Pythagorean theorem, if this is 4 root 3, if we do a squared plus b squared is c squared, that causes this to come back and be an 8. And same thing going this way is going to be an 8. And going this way is going to be an 8. So name two segments congruent to WE. We've got our choices. CW, RC, RE are all going to be congruent. So I'll just put RE in. It really could be any of those that make up the size of the figure. Let's look at number 2. If WR is perpendicular to CE, so let me erase out what we got here now. I'm going to erase this stuff out here. We're going to do the next part of the problem. Okay, switch colors up. So if WR congruent to or perpendicular, name all angles congruent to RCE. RCE congruent to this angle here. So this is a parallelogram. If this is perpendicular, that means this is a right triangle. These bisect each other. CO bisects CE. So this segment and this segment are congruent. This is congruent to a self-reflexive property. So this makes a pair of, if we do side angle side, well, yes, side angle side using the right angle is the angle. These, this triangle COR is congruent to triangle EOR by side angle side. Now, could we do it the other way too? If this is, so this is going to be congruent to there. It's congruent to here. We got vertical angles, right angles, adjacent angles. We actually, all these triangles are going to be congruent to each other, which means that all of these angles are going to be congruent. So we have angle RCE is congruent to angle REC, and that's also congruent to angle WCE, and that's also congruent to angle, or RCE RCE, REC, WCE, and WEC. Those are all going to be the congruent angles, because by side angle side, with vertical angles and with these being bisectors and setting up congruent sides, these all are all congruent by side angle side. Okay, number 3. If WR is perpendicular to CE again, name all segments congruent to WE. Now, W is this side. We saw in number 2 that all of these are congruent triangles, so all of these sides are also congruent. This is what we would really call a rhombus in a day or so when we have another lesson and learn a couple of new definitions. And a rhombus is a parallelogram. It's a special type of parallelogram where all the sides are congruent, diagonals bisect each other, and diagonals are perpendicular. So name all segments congruent to WE. WE is congruent to CW or WC. It's also congruent to ER. It's also congruent to CR. So those are all congruent sides with each other because of the congruent triangles set up by the perpendicular and the side angle side. Okay, number 4. If RE is equal to EW, R to E is equal to E to the W, or EW. And also, remember, this is a parallelogram and opposite sides are congruent. So if RE is congruent to EW, then the side opposite RE, which is CW, is going to be congruent to the side opposite EW, which is CR. So all of these sides are going to be congruent also, which sets up all these congruent triangles again. So name all angles congruent to ERW. ERW, which is this, what we call the vertex angle, because it's the sharpest angle. So ERW is congruent to CRW. And opposite angles are congruent, and they're bisected. Angle CWR and is also going to be congruent to angle EWR. So those are the congruent angles set up in this problem. Let's look at the next one here. Quadrilateral GRM is a parallelogram. Why is G supplementary to M? Well, if you have a parallelogram, these opposite sides are parallel. We mark them. And G and M are same side interior angles. Same side interior angles have to be supplementary when you have parallel lines. Why is M supplementary to A? Same argument. You got these parallel lines. This Lucy, hush. We got these angles parallel. This is the transversal. These are same side interior angles. They have to be supplementary. That's again because of same side interior angles in the parallel lines. Consecutive angles of a parallelogram are supplementary, while opposite angles are congruent. Okay, number 2, suppose that M is a right angle. What can you deduce about the other angles? If M is a right angle, then by same side interior being supplementary, G has to be a right angle. If M is a right angle, then by same side interior going the other way, A has to be a right angle. And then between these two parallel lines, R also has to be a right angle. So they're all right angles by same side interior with parallel lines.
Ow!
For number 6, must it be a parallelogram? If you look at the 270s, they're in corresponding positions, which makes HG and EF parallel to each other. And if you look at angle E and angle GF, say W, these are also corresponding angles, which means that these lines are parallel. If you have corresponding angles, congruent lines are parallel. So yes, you have pairs of opposite sides that are parallel. If you look at number 7, it's not a parallelogram because opposite angles are not congruent. If you look at number 8, H and E are supplementary to each other, which means that HG and EF are parallel to each other, but there's not enough information about HE and GF, and there's no information about them HG and EF being congruent, so you can't say that it's a parallelogram. In these next exercises, they're telling us that we do have a parallelogram, so we need to find the missing values here. Find A, B, X, and Y. If it's a parallelogram, opposite angles are congruent, so Y is going to be a 62. Opposite sides are going to be congruent, so B is going to be a 10. And opposite sides are congruent, so A is going to be a 10. Looking at number 6, opposite angles need to be congruent, so X is going to be an 80. PQ and SR need to be congruent, so B is going to be a 15, and A is going to be an 8. If this is a 30-degree angle, let's see what we got here. We got 80 and 30 is 110. This other angle here at Y must be 70 degrees. So altogether, these need to be supplementary. So this must be 70 degrees. That makes 180s. That makes supplementary by alternate interior angles. We got a 70 down there, or we got a 30 down here and a 70 there. And we found all the ones we needed to find. Looking at number 7, let me switch colors. We got 128-degree angle there, so X is going to be 120 degrees. This is a 38-degree angle there. There's going to be 38 there. This is a 5. A is going to be a 5. SR is a 3. PQ is going to be a 3. So we found that B is a 3. Let's see. This is 120. So this angle here must be a 60 because this needs to be supplementary. This big angle is a 60. That means this angle up here is a 60, but 38 of it's already given to us. And the difference of 60 and 38 is 22 degrees. So Y must be 22 degrees. Let's look at number 8. If this is let's call this M. If MR is 11, then MP must also be 11, so that gives us the B. If this is 33 degrees, this adds up to 103. This angle up here must also be 103 degrees. With parallel lines cut by a transversal, this is going to be a 50-degree angle. Parallel lines cut by a transversal, this is going to be a 70-degree angle. What else could we get? If this is a 33, that's 103, so this is going to be a 33. Together, these all have to be supplementary. This is 103, so 180 take away 103 is 77. 50 of it's already used up. This must be 22 degrees, and then using parallel lines and alternate interior angles, this must also be 22 degrees over there. So we've basically solved the diagram. Going this way, if this is a 9, A must also be a 9. Okay, these are a little bit harder to see. Okay, looking at number 9. If QR is an 8, then PS has to be an 8. If from the midpoint to R is an 8, then from the midpoint to P must also be an 8. If from M to Q is a 9, then from M to S must also be a 9. Together, these angles add up to 82 degrees, so this angle here must be 82 degrees. Supplementary, these two angles down here must be 98 degrees. And this angle up here must be 98 degrees. Let's see what's going on here in the center. This angle in the center here, let's see, do we have an angle given to, if this is a 56, this is a 56, 56 from 82 gives 26 degrees. This is going to be 26. And if we go this way, we got our 26, we got our 56. Let's see, what about going this way? I can't really read what this angle is here to let me know what this angle is. So I can't get this inside angle. See, 26. What can we do up here? I can't figure out what angle X is because I can't read what this angle is. If I could read this angle, we could do triangle sums and we could figure out what angle X is. Okay, let's look at number 10. If this is 6 and 4, together that whole length is 10. So this opposite length here must be 10. They're telling us this is a 45 with a 90, so this is also 45 degrees because we have a isosceles right triangle here. That tells us this is 4 and this is 4 because this piece is isosceles. And we need this angle X here. This angle X is going to be a right angle. That's going to be 90.